Okay, so year 12. For today we're going to be looking at exercise 1D in the year 2 book, which is on partial fractions. So the idea of partial fractions is that a single fraction, like this fraction here, where it's got the denominator is two separate linear factors, so x plus 1 is linear, x minus 3 is linear, can be written as two separate fractions, both with linear denominators. Okay, and so the kind of questions you'll get is where you need to find the value of a and the value of b. Now there's kind of two main methods for doing this. There's a method of substitution and the method of equating coefficients. I'm going to show you primarily how to do it using substitution, just because I think it's a slightly nicer, more standard method, but the textbook does show the other way as well. So to start with, just looking at the right hand side here, we're going to add those two fractions together. Now if I was adding those two fractions together, you'd know they'd need to have the same denominator. So the denominator would be x minus 3, x plus 1. Now, to get from this x minus 3 to x minus 3, x plus 1, I've times by x plus 1. So I get a lots of x plus 1, or x plus 1 lots of a. And then similarly here, to get from x plus 1 to x minus 3, x plus 1, I've times by x minus 3. So I get b lots of x minus 3, something like that. And that is equal to our left hand side, so that's still identical to this, 6x minus 2 over x minus 3, x plus 1. So now after that, because our denominator and our denominator here are equivalent, that means our numerators must be equivalent. So I therefore know that 6x minus 2 equals x plus 1 lots of a, or a lots of x plus 1, plus b lots of x minus 3. And then this is where the substitution bit comes in. So first of all, we are going to substitute in x equals 3 into this whole equation here. I'm going to substitute in x equals 3 and just watch what happens when I do that. So when x equals 3, well, 6 times 3 is 18. 18 take away 2 is 16. Over here I get a lots of 3 plus 1, which is 4. And then when I substitute 3 into this expression, 3 minus 3 is 0. So I've got 0 lots of b. So now I'm just left with, well, 16 equals 4a. And therefore a is 4. Okay. So now we need to make a similar substitution into this equation up here so that we can find out the value of b. So to find out the value of b, we need this to be equal to 0. For this to be equal to 0, I'm going to substitute in x equals negative 1. So when I substitute x equals negative 1 into this expression up here, I get 6 times negative 1, 6 times minus 1 is minus 6, minus 2 is minus 8, ignore that. When I substitute minus 1 into this bracket, I get 0, so 0 lots of a. And then minus 1 minus 3 is minus 4, so I get minus 4b. So if minus 8 is minus 4b, it therefore follows that b would be 2. And so now I can just rewrite the original partial fractions up here. So this is going to be a over x minus 3, so it is 4 over x minus 3 plus b, and b is 2, so plus 2 over x plus 1. Oh, sorry, let me just move it so you can see that. So we end up with 4 over x minus 3 plus 2 over x plus 1. And that's all there is to it. I will do a second example now, but I'd imagine you'll all do really well with this. Okay, so year 12 second example. This is a tiny bit harder because here we've got 3 different linear expressions in the denominator of a fraction, so it's going to end up being written as 3 separate fractions. So it's going to be a over x plus b over x minus 1 plus c over 2x plus 1, and we need to find the values of a, b and c. So first of all, we're going to think about what would happen if we added these 3 fractions together. So if we added these 3 fractions together, they'd need to have the same denominator, in which case the denominator would be x minus 1, 2x plus 1. Now, to get from x to x minus 1, 2x plus 1, I've times by x minus 1, 2x plus 1. So I get a lots of x minus 1, 2x plus 1. Then in terms of b, to get from x minus 1 to this denominator here, I've multiplied by x, 2x plus 1. So plus b lots of x, 2x plus 1. And then in terms of our c, to get from this here to this here, I've multiplied by x, x minus 1. So I get c lots of x, x minus 1, like that. And that is equivalent, we know it's equivalent because of this identity symbol up here, to 6x squared plus 5x minus 2 all over x, x minus 1, 2x plus 1. And so because of that, because they've got equal denominators, it therefore follows that the numerators must be equal. So 6x squared plus 5x minus 2 equals a lots of x minus 1. Okay, so it would be all right if you can just get from this step to this step in just one go. That's absolutely fine, but this is what this bit here, this middle kind of step, is why we end up getting to that. So now we've got to that, we need to make some substitutions to figure out what a, b and c must be. I'm going to start by figuring out what I'm going to start by figuring out what a must be. So to work out what a must be, I need to make b and c equal to 0. So to make b and c equal to 0, I can just say that x equals 0. So the first substitution I'm going to make is that x equals 0. So when x equals 0, the left-hand side of my expression is negative 2. And then here, when x equals 0, well, this is 0 minus 1 is minus 1. This is just 1. So I get minus 1a. And here, because x is 0, I get 0 lots of b. And here, because x is 0, I get 0 lots of c. So I've just got minus 2 equals minus 1a. Because of that, a equals 2. After that, to calculate b. So to calculate b, I need this bit here. I need these a and this c to be equal to 0. So, I've made a mistake in terms of copying this out. This should be bx, 2x plus 1 just here. Forgot that too. So to make this equal, I need to make a and c equal to 0. So I look at what a and c have got in common, which is this x minus 1 factor. And therefore, if I say that x equals 1, then a and c will become equal to 0. So we're going to say that x equals 1. So when x equals 1, I get 6 lots of 1 squared, which is 6. 6 plus 5 is 11. 11 taken 2 is 9. Here, as I just said, when x is 1, a is 0. Here, when x is 1, we get 1 times 3. We get 3b. Okay, so now we know that 9 equals 3b. b is 3. And finally, we need to make a substitution to work out what c is going to be equal to. So to work out what c is, we want to make a and b equal to 0. So we look at what a and b have got in common, which is this 2x plus 1 factor. So we need that 2x plus 1 to be equal to 0, in which case x is minus a half. So the final substitution I'm going to make now is x equals minus a half. I'm going to do this using my calculator to avoid going wrong. So when x is minus a half, on the left-hand side, we get 6 lots of minus 0.5 squared plus 5 lots of minus 0.5. 2, oh, that should be a plus 5 lots, shouldn't it? Which gives minus 3. Then on the right-hand side, well, this becomes equal to 0. This becomes equal to 0. And so I'm just left with this bit here, which is 0.5, no it's not, it's minus 0.5 times minus 0.5 minus 1, which gives 3/4 c. So if minus 3 equals 3/4 c, to find c you could divide by 3/4, so minus 3 gives c equals minus 4. So c equals negative 4. And then final thing, we know what a, b and c are. It would be good just to rewrite the initial kind of fractions up here with their correct numerators on. So our final answer would be 2 over x, because a is 2. B is 3, so 3 over x minus 1. And then finally, minus 4 over 2x plus 1. Just a note here, I mean, you could write plus and then minus 4. That would be weird. Don't do that. Because c is minus 4, just write this fraction as minus 4 over 2x plus 1. And that's it. You should be absolutely fine to have a go with this now, year 12. It is a little bit tricky at first, but it's quite nice. It's just some quite nice algebraic manipulation to have a go at. So have a go with the relevant questions and then let me know how you get on.